Hey guys, welcome back. We hope you had a great weekend. We're going to be picking up today and continuing function notation. So if you want to flip to page 96 in your notebook, you can follow along with us. So first we're going to start by taking a look at this graph. This blue line is graph H. And what we want to determine first before we try to use function notation is whether or not this actually is a function. So what do you think? Is this graph a function? Yeah, it follows the vertical line test, meaning every input has exactly one output. There is no place that I could draw a vertical line and cross this blue graph in more than one location. So now that we know it is a function, we can use function notation to find some inputs and outputs. So let's take a look at these 4 questions. Why don't you try them based on what we learned last week, and then we'll check them over. All right, so taking a look at this first one here, we're given h of 2 equals blank. So in this case, we're given 2, and we don't know what comes out. And since the 2 is in parentheses, that means we know that that 2 is an input. So what is the output then if the input is 2? Well, input, what does that refer to? Is that x or y? Input is always our x value. So what we're going to do is anytime there's a number inside the parentheses, we're going to look for that number for x. So I'm on the x-axis, I'm looking at the number 2, and now I'm going to follow that up to the blue h graph. And where it hits is 5. So we have this point right here, 2, 5. And in other words, when my input or my x value is 2, the corresponding y value or output is 5. So now we do the same thing with h of 6. 6 is our input, so we're going to go to 6 on our x-axis. We're going to follow that up until we hit the blue graph. This is where it hits at 6 comma what? At 6 comma 8. So when the input is 6, the output is 8. This one kind of works a little bit different. This time the 2 is on the other side of the equal sign, and this is h of blank is equal to 2. So what they've given us this time is actually an output. What does that mean? It means that what we're given this time is a y value. So now I'm going to go to the y-axis, and I'm going to look for 2. And I'm going to follow it across until I hit this blue line. And if I go across this way, nothing. But over here, I see a point. If I keep going across, I actually see another point. So there's 2 locations where my y value is 2. It's here at -1 comma 2. But also again at -5 comma 2. So that means there are 2 inputs that lead to an output of 2. And I want to make sure that I record both of those always. If there's more than one answer, I want to include that. So either h of -5 could equal 2 or h of -1 could equal 2. What about this one? This time it says some input leads to -1. So let's go to -1 on the y-axis. We'll follow it across till we hit the blue h graph. And that happens right here. So where is this? This is probably -8, comma -1. So when my x value is -8, my y value is -1. Now let's take a look at a table. First, before we try to use function notation, is this actually a function? It is, because each input or x value leads to only one y or output. There's no place where I see an x value repeated, but with a different output. So this is a function. Let's go ahead and try to use function notation here. Try to answer these 4 questions, and then we'll come back and check them. All right, so first let's start with these first 2. These are probably the easier ones to understand. Again, when I have a number inside the parentheses, that will be an input. In other words, we're given the x value, and we'll have to try to find the output or the y value. So I'm given an input of 3. So let's go to the x column. Let's find 3. And I see the corresponding output or y value is 5. What about the next one? Here we're given an input of -4. So again, go to x, find -4. We see the corresponding y value is 9. These ones are the reverse. Remember, if I don't see what's inside, I don't know the input. What I do know is the output, which again would be our y value. Or in this case, you can see they're not using y, they're using f of x, but y and f of x are the same thing. So let's look down this column for -5. Here it is. The corresponding input is 0. So in other words, when 0 is my input, my output is -5. The last one we're given is 7, and 7 is our output. But it turns out that when our output is 7, our input is also 7. What a coincidence. All right, let's try one more. This time we're given an equation. The equation says g of x equals 3/2 x plus 18. Is this going to be a function? Yes, it is. What type of function do you think this is? It's a linear function. We can tell because it looks like y equals mx plus b. So now we're going to try to do some inputs and outputs with our equation. This time we see that g of -8 equals something. We don't know what, so we're going to try to find what. When we're given the number inside, remember that's like them giving us our x value. So we're going to solve this just by substituting in that -8 anywhere I see an x in my equation. And that happens right here next to this 3/2. So I'm going to go ahead and write this out. And now what I'm going to do is I'm going to basically ignore this left side. And I'm just going to calculate over here on the right side using PEMDAS. And what I can do is I can just put this over a 1, and I can multiply straight across. So 3 times -8 will make -24, and 2 times 1 will make 2. And now we're just going to go ahead and try to divide this, and it does work out nicely. We get -12. And finally, we're going to add. We get +6. Now, something that I notice people want to do, and this is a really common misconception, is they like to say, hey, we're not done. They see this -8 over here next to g, and they think that that means that they're multiplying, and they think that means, well, we got to get the g alone, so shouldn't we divide? And in reality, that's not what's going on here. This is actually just a mathematical sentence. It's saying the g function or the g equation that's up here, when I put in -8, I get out 6. It's just a sentence. It's not something that needs to be further solved. We're actually done at this point. So again, when my input is -8, I get out 6. What about this one? This time I'm not given an input, but I am given an output. So in other words, I know what the answer is going to be. I just don't know the x value that would allow me to get there. So how do I find that? Well, I know I should be getting out 27. So on this side of my equation, instead of writing g of x, I don't know what x should be. So I'm going to replace this whole thing, this whole output side, with 27. And I'm going to leave the right-hand side with x, because I don't know what that input value should be. I'm going to have to solve for it. So now I'm going to do my inverse operation. So I'm going to draw my wall, and I'm going to start by subtracting. And what I get here is 9. So 9 equals 3/2 times x. And then if you guys remember how to cancel out a fraction, either in this case we could divide by 3/2, but that would be the same as multiplying by the reciprocal. So that's kind of an old skill. That just means we want to multiply by the flipped version of this fraction. And that would let us cancel out the 3 and cancel out the 2's. And whatever I do to one side, I also have to do to the other. So over here, I'm also going to multiply by 2/3. When I multiply by a fraction, I've got to make this guy a fraction and multiply straight across. So 2 times 9 makes 18. 3 times 1 makes 3. So over here, x is alone. X equals 18 over 3. Well, I know what that equals. That equals 6. We got 6 again, but this time 6 is our input. So when I put 6 into the g function, in other words, if I put 6 in here, I would get out 27. Whereas over here, I put in -8 and I happen to get out 6. That's just a coincidence. What about the last one? Why don't you try that one on your own? So if we try this one together now, what we are given is the output. So again, I'm going to set this up as follows. I'm going to put the 15 on the output side instead of the g of x. And I'm going to write out the equation. And then I'm going to have to solve for x because again, I have this big blank here. I don't know the input. I don't know what should go in for x. I'm going to have to solve. So let's subtract 18. And this time we get -3 equals 3/2 x. Again, we need to cancel out this fraction, and the best way to do that is just to multiply by the reciprocal. So I'm going to be multiplying by 2/3. And whatever I do to one side, I have to do to the other. Put this 3 over a 1, and we're going to multiply straight across. So 2 times -3 is -6. 3 times 1 is 3. And if I divide this out, I get -2. And that is what equals x. So in other words, if I input -2 as my x value, then I'll get out 15. So now you're going to get to go ahead and try this a little bit more on your own through Edulastic. So once you're ready, you can go ahead and give that a try. Good luck, guys.